What does load average mean on Unix/Linux? If I run uptime, I get something like this. What do those numbers on the end mean? The man page tells me it's the load average of the system over the last 1, 5, and 15 minutes. But what is the scale? Is 1.27 high? Low? Does it depend on my system?
Load average is a gauge of how many processes are on average, concurrently demanding CPU attention. Generally, if you have one process running at 100%, and it just sits like that for all eternity, you can expect all values to approach 1. Generally, this is as efficient computing as you can get, no losses due to context switches. However, on modern multitasking OSes, there is more than one thing that needs CPU attention, so under a moderate amount of load from a single process, load average should float between 0.8 and 2. If you decide to do something insane, like build a kernel with make J60, despite only having one logical processor, then load average would rush towards 60, and your computer would be incredibly useless to you, death by context switch. Also to note, this metric is irrespective of how many cores/cores there are. For a 2-cored system, running one process that consumes a whole core, leaving the other idle, results in a load average of 1.0. In order to decide how loaded a system is, you'll need to know the number of cores and do the division yourself.
man5 proc /proc/load of the first 3 fields in this file are load average figures giving the number of jobs in the run queue, state R, or waiting for disk I/O, state D, averaged over 1, 5, and 15 minutes. They are the same as the load average numbers given by Uptime 1 and other programs.
I cite from a reference of a course. Load average is the average of the load number for a given period of time. It takes into account processes that are actively running on a CPU, considered runnable, but waiting for a CPU to become available, sleeping, i.e., waiting for some kind of resource, typically I/O, to become available. I cite further about interpreting load average. The load average is displayed using 3 different sets of numbers, as shown in the following example. The last piece of information is the average load of the system. Assuming our system is a single CPU system, the 0.25 means that for the past minute, on average, the system has been 25% utilized. 0.12 in the next position means that over the past 5 minutes, on average, the system has been 12% utilized, and 0.15 in the final position means that over the past 15 minutes, on average, the system has been 15% utilized. If we saw a value of 1.00 in the second position, that would imply that the single CPU system was 100% utilized, on average, over the past 5 minutes. This is good if we want to fully use a system. A value over 1.00 for a single CPU system implies that the system was overutilized. There were more processes needing CPU than CPU was available. If we had more than one CPU, say a quad CPU system, we would divide the load average numbers by the number of cores. In this case, for example, seeing a 1-minute load average of 4.00 implies that the system as a whole was 100%, 4.004, utilized during the last minute. Short-term increases are usually not a problem. A high peak you see is likely a burst of activity, not a new level. For example, at startup, many processes start and then activity settles down, If a high peak is seen in the 5 and 15 minute load averages, it would maybe cause for concern.
In general, it measures the number of active processes at a given time, but the metrics used to calculate it differ on some systems. The only article I've found that explains it fairly well is this one.